welcome everybody. My name is Julia. I'm a PhD candidate at the TU in Eindhoven, and I'm working together with the TU in Munich on my PhD, a topic neurosymbolic AI for material information. And today I'm here together with my co-authors, Stavros, Nousias, Ekaterina, Petrova, André, Borrmann, Pieter, Pauwels, and present our paper on vision language model augmented RAC frameworks for ontology-constrained LLM reasoning to detect material information in existing buildings. The built environment is responsible or contributes significantly to the global waste generation. And this has mainly also to do with the lack of material reuse or inefficient use of materials as such. Particularly existing buildings before the 90s do not have a lot of information and documentation recorded with BIM models or any digital records as such. So besides point cloud documentation, non-destructive testing methods, building engineers many times still walk around on the construction sites, document via imagery, and search in their PDF documentations about building permits of some sort to understand what type of wall constructions, floor constructions, and also what type of materials can be in there. So indeed, what they do is, in talking in a Dutch context now, construction engineers walk around, make imageries from the outside and the inside of the rooms, and try to understand contextual information from their own knowledge, from their own what they see, like what building type, what construction year, where was it built, what kind of materials do they see on the surfaces, and so on. With this information, they kind of try to access or filter out from existing PDF documents, like building permits as such, and filter down to particular paragraphs which they can use, right, to make further decisions and or further understand what materials could be possibly behind the walls in there. The challenge, however, remains quite a lot to structure this information according to a systematic decomposition of a building, how it is composed, or a building taxonomy, meaning what information we have on a building level, on an element level, or on a material level. And why we want to do this? Simply because we want to not only reuse the materials, but we also want to understand a reusable data structure of how we document this information. So we can scale this assessment of a specific building type also for other related building types later on. So therefore, we propose this framework, which is an interplay between three technologies: the vision language model, to detect classes of images as we see them. Then we also use a retrieval-augmented process together with an LLM to extract information from the documents. And we use the semantic graphs to structure and use ontological concepts to enrich and to structure information according to our domain knowledge. So the overall view of this method that we tried out is step one, a vision language model, where we use CLIP, simple classification task, where we want to understand building types and material categories. We then already know, together with this vision language model results and some other context data from the building we observe, we can already reach parts of our semantic graph as here. We then use this structured information already for our RAC process to filter down or fetch information from our massive chunk on PDFs and use the most matching descriptions. Then what we do is we use this in clip predictions, the RAC extractions, and we use it into our LLM modeling reasoning framework that allows us to then use together or map basically the description, the text chunk, to the ontological definitions so we can further enrich information. And in this case, besides the VLM, which is the building type and the material category, we want to fetch a generic description per building element, so for wall, floor, roof, so basic elements. And out of this text chunk, we want to then enrich layer set definitions, whether it's a cavity wall, multi-layer, is it insulated, has it an air gap, etc. and the associated material types for each of those layers. So we have these 3 steps, and the underlying code blocks more or less address exactly the VLM, the RAG process, and the ontology-constrained LLM reasoning. So for the first step, we use the clip, a mentionary clip model as a zero-shot prediction, where we encoded a bunch of images, and we used a couple of prompts. We tried to not train, but fine-tune as much as possible with these prompts. And you can see we also make descriptions so that the VLM better understands what type of classes he can predict. We do this for the building type and also for the material types. And then as a result, we can already see some class definitions and confidence scores, very relevant, that the user also understands how likely or how much certainty it comes with. We then use this information for a specific retrieval query. So based on this context information with the VLM predictions, we can extract particular text chunks. So we have documents like building permits, archetype descriptions, and governmental descriptions about how these archetypes were built. Then we basically combine this into our corpus, and each of those descriptions are then basically tokenized so that we can simply extract this based on our evidences we have. And the good thing here was already that all of these documents were kind of structured in a similar way that allowed us to make sure that each construction year, each building type, and each element in this building type was addressed. So then how the matching works, so we have already existing context information, and based on that and the cosine between the text in the corpus and this meta graph, we can then already map and take the highest likely description out of there. So basically we narrow down, right? We have a massive amount of PDFs, and now we already have like only a couple of lines that most likely fit the building that we observe. Now the LLM takes all of this as an input, like it takes the retrieve query, the text chunk of the archetype description, and also the ontology as sort of a dictionary with all the classes inside and what they mean as well, very important, and tries to reason a specific RDF turtle structure as we feed it as a certain template. And important to mention here is that at this point, the LLM started hallucinating as wildly as possible. So we tried really to include this fallback logic that it allowed only to take out from this old definition as we have it. And if we do not map bigger than 60% or something, then we keep it as a description and we go on from there. So as an example, we have here a terrace house with a brick facade. We detect with the VLM, with the confidences. Then in the RAG process, we received this text description, and out of this text description, we semantically could map towards the ontology constraint and read that this building most likely has a cavity wall with an empty layer, I believe. And the outside layer of the facade is a clay unit. And this has to do with, of course, understanding in what time it was built and in what most likely materials were used in that time, what we could read in this text. We validated this with almost 100 images, which we were manually labeling with engineers together because they usually make these tasks out of their mind, right? They walk around and write all of this down. And eventually the results were, we had confidences between like 45, 65, something like this. Not the greatest, because it was also very, it was very difficult because there was a lot of different construction types and building types, so we needed to narrow down in the validation set. But out of this reason, because the validation was in the middle range, we tried since then a couple of additional steps to really understand how we can structure the text chunks in a semantically meaningful way. not only by feeding the LLM with ontology definitions, like class definitions and descriptions, but with really the old axioms, meaning the domain ranges, the subclasses, the possible information that it can infer, like if this, then like certain logics maybe we can already include. And this already allowed us a little bit to understand better how we can interpret different chunks of the text with particular classes in a specific hierarchy. Yes, I think I'm just in time. Thank you very much.